People, welcome back to my YouTube channel. To my returning subscribers, you people are truly the best. We wouldn't have reached there without your earnest and continuous support and show of love. Thanks for always being there. To you that just seen this video for the first time, please click on the subscribe button, click on the share button, click on the like button. You could also comment. You could also tell us how you feel about our video. You could also ask questions where you are lost. Thank you. Now, today we're going to be talking about basically the medical laboratory scientists. You know that as a medical laboratory scientist, there are other things that can fetch you million in this our profession without your normal traditional 8 to 5 job. Things like reagent production. Most of us have forgotten that aspect of med lab. You know that quality control is our thing as medical laboratory scientists. So reagent production should also be our thing so that we will know when the reagent is giving us what we want and when it's not giving us what we want. So, because as medical laboratory scientists, we often know the nitty-gritties of our chemical pathology, our hematology, our parasitology, our microbiology. So we are supposed to be producing the reagent we use in these branches of medical laboratory science. For our clinical chemistry, we could produce as a lab scientist glucose, LFC, LLT, bilirubin. For hematology, we could produce our stents, our diluting fluids, and also our buffer. For our microbiology, you and I could also produce our sensitivity dates. Most of our air we can do that. So why have we not gone into this? Why are we not thinking towards this angle? You know that reagent production is a highly lucrative field in medical laboratory. So today we are going to be talking about trees EDTA borate buffer. So we're talking about trees EDTA borate buffer. You could produce this buffer and supply to clinics. You could also supply to laboratories and research institutes. So today we are going to go into the production of trees EDTA borate buffer. So also do not forget that in reagent production you have to know your niche. Knowing your niche entails knowing the availability of the chemicals they are going to be using to produce these reagents. Number one. Number two, also you need to know the demand. You don't just wake up and start producing stents or start producing buffer because you feel like producing. No, you should know in your area, know the demand. Is buffer widely needed in your area? Is it feedstock A or B that are widely needed? So the first thing to do is knowing your niche. So for the production of trees EDTA borate buffer, these are the materials that we need. I'm going to show us some of them. These are boric acid. These are EDTA. These are trees buffer. These also are weighing balance. In there, we have our filter paper and we have a spatula because we need this spatula to measure each of the chemicals separately. Now, the materials needed include materials needed. Number one, we said our digital weighing balance. Number two, we said our spatula. Number three, we said Wattsman number one filter paper. Now we are now going into the chemicals. The chemicals that we need trees hydroxy methyl amino methyl. Number five, we need EDTA. And number six, we need boric acid. Number seven, distilled water. And number eight, 1 liter flask. So these are the materials we need for the production of this trees EDTA borate buffer. We all know what we use as laboratory scientists. We know what we can use our trees EDTA borate buffer for. You know, for our HB electrophoresis, we use this buffer for to get a good separation. And in this production, we need pH of 8.5. We need this buffer to be at this pH. At this pH, this buffer can separate well without any form of issues. So we are going to enter into the methodology. So for the method of production, which is very, very important, our number one reagent we said is trees hydroxy methyl amino methyl. We will be needing 10.2 grams of this. Now for our EDTA, we need 0.6 gram. For our boric acid, we need 3.2 gram. Please, this measurement is for production of 1 liter. 1 liter of trees. And number four is distilled water, which is 1 liter. So what's the procedure? Number one, the first thing we do is to correctly weigh all the chemicals separately. Why did you say you will first weigh separately? So that you will know the exact amount, so that you don't exceed these values that we gave. If we are saying trees is 10.2, when you're weighing separately, just give us 10.2. So you have to weigh correctly. That's why we are using a digital weighing scale. Now, after weighing separately, pour all chemicals into the 1 liter flask. Into the 1 liter flask. You now, after weighing them separately, let's assume you weigh trees the first time, you pour it into your conical flask or your beaker that is 1 liter. Then your EDTA, after weighing 0.6, you pour inside into the same conical flask, your boric acid, like that. Now after this, add about 500 mils of distilled water. We say we are making for 1 liter, but the first one we are going to add, we'll add about 500 mil. Why are we adding about 500 mil? Because most of us might not have a magnetic stirrer that can help us dissolve this salt. So when we add about 500 mil, which is half of the 1 liter, then we will now make sure that we dissolve the salt properly. That's why we're adding about 500 mils of distilled water. Then number 3, make it up to the 1 liter mark with distilled water. So after you must have dissolved, you now make it up to the 1 liter mark with distilled water. So what next do? You now get a sterile, airtight container and pour the buffer for storage. Store this buffer at 2 to 8 degrees centigrade. So we have to stop because we don't want the pH to go down. Because if the pH loses its potency, the buffer won't separate properly. So you store at 2 to 8 degrees centigrade. Now, because the measurement we gave is basically for 1 liter production. Now, you as a lab scientist that is going to enter into large production because you want to sell, you want to supply to hospitals, you want to supply to laboratories and research centers. So we are going to show you how to calculate to get the actual volume and actual grams that you need for your production. So assuming for a start you want to make like 5 liters, the first thing we did is for 1 liter. So assuming you want to produce for 5 liters, how do you go about getting the volume, the measurement, the correct accurate measurements for your trees, for your EDT and for your boric acid? So we'll now say for trees, we said it's 10.2 grams in 1,000 mil. 1,000 mil, we know as scientists that is equivalent to 1 liter. So for our 5 liter, which is 5,000 mil, is X. So when we cross multiply, this is going to give us 51.0 gram. So for our 5 liter buffer, we need 51.0 gram of trees hydroxymethyl aminopentane to produce 5 liter. Now for our EDTA, we will apply the same principle. So we said earlier that 0.6 gram in 1,000 mil. So in 5,000 mil, this will be giving us about 3.0 gram. So it means we need about 3.0 gram of EDTA for our 5 liter buffer. Now for our boric acid, we said we needed 3.2 grams in 1,000 mil. So in 5,000 mils X, so we are going to be needing about 16.0 grams. So for our boric acid, we are going to be needing about 16 grams to make 5 liter. Now, if you want to produce more than 5 liter, you can apply same principle and you will get your actual values. You get your correct measurements. So we also require a pH meter because you need a pH meter to check if this buffer is actually within the normal pH that is required. So if it's not there, we are going to be discussing how to adjust the pH, assuming the pH is acidic or is more alkaline. So we are going to be discussing that in our next video. Also, we will also be talking about the production of Fiston A, Fiston B, our touch solution, our Leishman, before we enter into other reagents. Thanks. If you watched this end, it means you enjoyed the video. Please like, please share. If you've not subscribed, please do so to subscribe. Also click on the bell icon to get notified each time we come online. Thank you. Bye.